is yours.
Thank you for the introduction. And so today I'm going to talk about thermal comfort in historic concrete buildings. The project is named FRESCO. It's a cooperation between our laboratory of research on historical monuments, Myriam and I make part of. It also gathers another team from Centre de Recherche sur Institut de Recherche en Constructibilité, Andrea Kindinis, Francesca Contrada, Arnaud Leperto, the Fondation Le Corbusier with Bénédicte Gandini, and Direction régionale des affaires culturelles d'Île-de-France avec Marie Montfort. So now let's go to a few words of context about climate evolution's impact on concrete and humans. As you all know around the table, I'm sure, there has been several projects about global warming and impact on cultural heritage, such as Noah's Ark or climate for culture. And one of the findings, for example, for Noah's Ark perspective in the long term, was the probable increase of the thermal stress, which means also differential thermal dilation problems. Now, if we focus on France, those data are coming from Météo France. So on the left graph, you can see the average annual temperature, the difference with the reference, which is 1961 to 1990. And so you can see a clear increase in the temperature. And here in the second graph, you can see the prediction for the far future with the several hypothesis scenarios. This one being the worst. Now, the consequences on concrete. Here you have the example of the Le Corbusier Gardener's Pavilion in Villa Savoie in Poissy, France. And here on the left, you can see the Gardner Pavilion. And here you can see infrared pictures of it, showing that we can clearly see the differences in dilation, possible dilation, due to the fact that the structure of the concrete the structure of the building is made of concrete, and it's filled with brick blocks, hollow bricks, and clinker bricks. And this generates differential thermal dilation, as you can see here, with a lot of cracks from the outside. And inside, we have a lot of problem of water percolation and salt crystallization. And here you get a second example from Le Corbusier in Pessac, Cité Frugès. And as you can see, we have exactly the same type of cracks due to the same origin. Now, come back to climate evolution and especially intense events. Again, coming back to Météo France data, on this graph, you can see the evolution of the number of warm days from 1970 to 2005. And so you can see a clear increase. And if we go to this one with the evolution for the far future, using again the worst scenario, hoping it will not happen. But it's just to give you an idea, then the increase will be enormous. Now, if we come to the climate evolution dealing with rain, on the left graph, again from Météo France, you can see the evolution of the yearly cumulative precipitation between 1976 to 2005. And what we can see that we have an increase in blue of the rain in the north and a decrease in the south. If we go to the yearly cumulative precipitation with the worst scenario, it's the same trends with higher precipitation in the north and lower in the south. And it's even more obvious if we have a look on the difference between summer and winter, with the darker here, the less precipitation, and on the right, in winter, the highest, the bluest. And this can have a clear impact with the water infiltration during the winter time and salt crystallization in summertime. So to make a synthesis, higher average temperature, annual temperature are expected higher sudden and intense climate events too, which in that case means warm days. We are going to drier summers and winter's weather, so it will also increase the thermal comfort for humans. And for materials, I don't have time to go into details on the other aspects of the degradation of concrete due to climate evolution. If we just focus on the temperature, higher temperature and sudden and intense climatic events will favor thermal stress. Now, a few words also about historic concrete in France. We made a survey within the frame of a European project that was supported by the GPI, which name was Red Moneste. And what we found is, you can see on this graph, a clear increase, an exponential increase of the amount of monument made of concrete listed in France. We had 217 in 1994, and now in 2021, we have more than 950. These cultural heritage is spread all over France, including the islands, so that we have varied climates from continental to tropical. And if we go into details in the typologies of monuments that are listed, we can see that the main, the most represented typology is domestic architecture in blue here, which is subjected to thermal comfort issues. So that is crucial to work on thermal comfort. So first, probably most of you know that, but for my part, I didn't know so. A few definitions about thermal comfort. It has been defined as that condition of mind that expresses satisfaction with the thermal environment. It's according to the standard for evaluation indoors environments. There are three main indicators to evaluate the thermal comfort: the PMV, the PPD, and the PPD versus PMV. The PMV, sorry. The PMV index is an objective prediction of the mean value of votes of a group of occupants. It takes into account several parameters such as the metabolic rate, the sensitive heat losses, and so on. And the read of this indicator is according to a 7-point thermal sensation scale, with 0 being the optimum comfort, -1 and +1 being tolerable, and up to over 2, it's clearly uncomfortable. Sorry. And 3 means intolerable. The second indicator is the PPD. It's a quantitative index, a quantitative prediction of the percentage of thermally dissatisfied occupants, and it's a subjective indicator, which is calculated from the PMV. So it's the predicted percentage of dissatisfied. And then to evaluate the comfort, the thermal comfort, we need a holistic approach that integrates both indicators, thermal comfort being achieved based on a 80% occupant satisfaction rate or more. Now let's come to the FRESCO project. The name means Confort thermique édifice Corbusier. We have 4 partners, l'École spéciale des travaux publics, LRMH, the Le Corbusier Foundation, and DRAC Île-de-France. It's supported by the Commune Paris-Est within the Amorçage Call. And the aim of the project is to study the thermal comfort issues in historic concrete building through the example of 3 sites designed by Le Corbusier. The idea is to explore a resilient solution to face the ongoing global warming. So to improve indoor thermal comfort, to reduce energy consumption, reduce material deterioration, and all those solutions being consistent with the ontological charters with limited restoration actions possible. So the methodology we adopted was first a documentary study, then field surveys, then on-site physical measurement and diagnosis, the fourth being modeling and recommendation of solutions, and the fifth on-site experiment of innovative resilient solutions. And the 3 sites are Le Corbusier Studio Apartment in Molitor, the Villa La Roche, and Villa Jeanneret. So now let's come to the first findings of the documentary study. The objective were to identify original architectural solution to ensure good thermal comfort. Because some of the architects, such as Le Corbusier or Perret, did think about that point right from the beginning when they designed their building. But very often people that are living in those places have blocked all the ventilation systems and in order to improve their thermal comfort. But finally, it's the reverse that is happening. Then for for each site, we have a creation of a chronology of restoration, resulting effects of the intervention has also been identified. And we have identified also innovative resilient solutions. So here is the example of findings on the, we're going to focus now on the Le Corbusier studio apartments. And so we found such type of designs with evidence of the chronology of the restoration from the archive of the foundation. We also have a series of pictures. Here you've got the apartment in 1934 and the workshop in 1960. So to summarize the result for the apartments, it was built between 1931 and 1935. Until 1965, modifications were made by Le Corbusier. After his death, punctual interventions were made by the foundation. And between 2014 and 2018, a higher restoration operation was occurred with the conservation of the last state and restitution of the polychromies of 1965. The field survey, we have identified different problematics for the studio. The problem was thermal comfort in relation with the facades with single glazing that you can see here. And energy consumption was too high. So the analytical protocol adopted was air temperature and relative humidity sensors of that type, blowing door and thermal comfort station with a different type of measurements, instant, short period, and continuous monitoring. For the Villa Jeanneret, materials degradation and was mainly due to condensation phenomena, which it is the main problematic. We've got the same type of measurement plus surface temperature sensors, which are here. Then for the Villa La Roche, we had as problematics material degradation, mainly due to condensation phenomena, thermal comfort in the office, and energy consumption too high with the same type of methodology. And now, if we focus on the studio, we've, the ESTP has implemented some sensors, an outdoor weather station here, in red, indoor climate stations in the entrance workshop and bedroom, and data loggers in the living room and in the kitchen. Here are the types of measurement that are made. And here is the implementation of the system in the apartment studio. Here are the results. This is the cumulative frequency during August 2022, measured in the entrance. And what you can see here in green is the temperature outdoors, and in yellow and orange, the temperature indoors. So what we can see is that we have clearly higher temperatures indoors than outdoors. Throughout the months, more than 95% of the values were higher than 26 degrees, which is a reference value in summer, according to Fenger theory. And the dark globe values are a little in yellow, the highest, and they are following the same trend and are slightly higher than the temperature indoors, which means heat storage of the materials. Now, if we have a look on the warmer day of August, we can see here is the day between the two red lines. We have up to 36 degrees in the workshop during the day, and a very slow decrease of temperature during the night here and here, with a still 27 degrees at midnight. So it would need night ventilation to improve the temperature, the thermal comfort during the night. Now, for the cooler day of August, in the same area, we have even on the cooler day, what we can see that we are up to 35 degrees in the workshop, and we are much higher than the 26-degree temperature of comfort, which means thermal inertia. Then if we go to the PMV index in August, we can see that the PMV threshold for warm discomfort, which is 2 and around 30 degrees, is exceeded several days in the month. So the first limit is of 1 is there in blue, and the second one, which is intolerable, is 2. So we can see that it's very high. If we go to the PPD index, we can see that we have a large majority of dissatisfied people through the months with a clear thermal discomfort. Now, if we come to the conclusions and solutions, the conclusions are that the 2022 hot summer is in concordance with the expectation of intense climatic events prediction in France. We have seen thermal discomfort clearly evidenced both during the day and the night, with heat storage of the materials and slow temperature decrease during the night. So the first possible resilient solution identified were to use a mechanical forced ventilation to introduce it using the existing air ducts, because this ventilation does not exist at the moment. And we are also going to perform experiments with a new generation of vacuum insulating glasses with higher insulation properties, but almost as thin as historical glass. They are designed by Fideo. You can see here an example. And with this system, you have the same result as 3 layers of insulating glass, but they are thin as historic glass. So the window frames can be conserved. The next step are innovative to look for innovating solutions again, to make some measurement on site on winter time, to go on numerical modeling and to analyze the result retained in the numerical study phase, and finally to make summer experimental campaign with implementation of the resilient solution, such as the new glass that we've seen. And thanks to all the partners of the project, and special thanks for Andrea, Francesca, and Benedict for their help to prepare this presentation. And thank you for your attention.